All right, so today what we're doing is we're graphing absolute value functions. So we take the algebra out and we're going to graph. So go ahead and grab your calculator and don't just pretend, actually go grab it, because I'm going to show you how to get to the functions on here so that you see this. So it says use your graphing calculator to graph this line. All right, so this is a line, there's no absolute value. So from y equals, we're going to do 2x, we're going to do 2x minus 4. And then we want to graph this in a standard window, so just do zoom 6. Zoom 6 gives us our standard window, and there's our line. So if we look at this, we actually don't even need to graph this on the calculator. So we know that this is in the format of mx plus b. We start with my b, so I go to -4, so 1, 2, 3, 4. And then this is my slope, 2 is my slope, so I go up 2 over 1, up 2 over 1. And so here is my line. Ooh, not too bad, kind of straight, which is what I see here. So this is zoomed in, but if I count down 4, I see I go through this 0.20, which is 20, so here's my line. Okay, so we're going to leave the line on a paper, and now what we're going to do is we're going to make this an absolute value. So if you look at what's on the inside of this, this is a line. This is what we just graphed, right? 2x minus 4. So this is a linear function inside my absolute value bars. All right, so let's look and see what happens, and then we'll talk about it. So we're going to leave this line on here, but we're going to graph another line. So go back to y equals, and go down to y2. This is our second line. Now, to get those absolute value bars, what you're going to do is you're going to hit math. This is this math button underneath the alpha. And then you're going to go over to num. And the very first thing you see is abs with a parenthesis. So we're going to hit abs. And now we have the absolute value bars. And so inside of this, we're going to put 2x minus 4. So the same function on the inside. Okay? And now we're going to hit graph again. All right, so what you see on your calculator is that this part of the graph right here until we get to this 0 is the same. They overlap on the two graphs. But what you'll notice is going the other direction, I'm going to go up 2 over 1, and I'm going to go up 2 over 1, and this part of my graph is my absolute value part of my graph. Okay, so now that we've seen this on the calculator, we're going to put the calculator away, and we're going to do all of these by hand. So I have this line, and if I think about what I have going on this line, really what happens is that this line keeps going, but this one, my absolute value line, is a reflection of this line. If you remember, we say that we cannot have a negative absolute value. So what happens is when we take those values and we solve an equation and we have our plus side and our minus side, well, because it has to be positive, that's why we always take this value, whatever it equals, and we change the sign. Because what happens is now this is a reflection, so we take this part of our line and it's only positive, and that's because we can't have a negative. So because this turns positive, it's the same values, but on the positive y. So whatever value I had here, so for example, this is at -2, this value of -2 now becomes a +2. This value here at -4 now becomes a +4. Now these values didn't change because they were already positive. All right, and so that's really what we notice. What's the difference between the two graphs? So my linear function can be negative. And my absolute value function, has only positive y values. Okay, and it says use this concept of absolute value to explain why this makes sense. Well, I kind of already did that, right? We know we can't have a negative y value. All right, so now we said put the calculator away. So now we're going to sketch this graph of y equals -3x minus 1. So again, this is mx plus b. So we're in a line right here. So I know I always do my my intercept value first, so I have -1. And now I have this -3x, so I'm going to go down 3 over 1. Up 3, left 1. So here's my line. I don't have a ruler. I wish I had a ruler right now. So I'm going to have something that looks like this. So what do you think is going to happen here? Well, what's going to happen here is that my value that I have, these negative values, are now going to be positive. So it goes negative at this point, not this point, right? This is where I see my first negative. So what I can do is I can just make this symmetric. And if you remember, we did symmetry when we had, when we were graphing parabolas, right? So we have this axis of symmetry. Well, this is my axis of symmetry wherever I hit my x-axis. So what I know is, because of this value, I'm going to have another value that's going to be at the same spot. And it's probably, if I go over halfway, it's like probably going to be right about here. So this is what my absolute value function is going to look like. So I have this looking value right here. That's my absolute value function. So how do we do this? We're going to graph the inside. So we're going to graph the inside and then make all y values positive. Okay, let's flip it over. So we know that the basic absolute value function, my parent function, is going to be y equals the absolute value of x. And this is called the parent function. Now we've done other parent functions this year. We've done y equals x, we've done y equals x squared, and now we're doing y equals the absolute value of x. These are all parent functions. That means there's no transformation. It's not shifting to the left or the right. So what does this graph look like? Well, this graph is a V, and it is a definite V. We said that our quadratic function here is a U, but this one is very, has a very precise point on it to make it a V. All right. Now, what is the slope of my parent function? This is super important. So if I have y equals the absolute value of x, this value right here is going to be the slope. And when there's nothing there, then my slope for this one is just going to be 1. We have this implied 1 right here. All right. Now, what we see, and let me go ahead and just draw my parent function. So if I have a slope of 1, it's going to look like this. And we already know it's going to go like this. Now, how do I know that it starts at 0, 0? Well, I'm just going to put numbers in. So if I put 0 in, I get 0. If I put 1, I'm going to get 1. If I put -1, I'm still going to get 1. So this V, this V is my parent function. All right. Now, the domain. Remember, the domain are my x values. And if you look at this, it's going to go on and on and on in the positive infinity direction. And it's going to go on and on and on and on and on in the negative infinity direction. So what we say is that our domain is going to be all real numbers, which is the same as -infinity to infinity. Now my range, these are going to be my y values. And with my parent function is right here. I cannot have any negative values on my parent function, so this is going to be 0 to infinity. Now, this is important. This is going to be a bracket. And the reason why it's a bracket is because this point right here is closed in circle. I can have the absolute value of x, I can have 0, because the absolute value of 0 is just 0. So I know that this has to be included. Okay, now, this is something that's pretty cool. So if we remember vertex form of a parabola. So here's our vertex form. So this is y equals a x plus or minus h squared plus or minus k. This was my vertex form of my parabola. So what does the 2 on the inside of the graph do? Well, here's my 2. This is going to mean I go left by 2. What does the 3 at the end mean? I'm going to go up by 3. What does the 4 at the beginning of the equation do? this tells me my slope, which is really, because we don't really have a slope in a quadratic, this is the first point to the left and right of the vertex. So we wouldn't keep that point going, it's just the very first point. So here we would go over 1 and up 4 in both directions. Now, here is the thing that's so awesome about this. It is the same thing for our absolute value function. So here is my new formula. My formula is going to be, I'm going to write here, y equals a x plus or minus h plus or minus k. Okay, so my rules apply the same. This is going to be my left or right, this is going to be my up, and this a value is going to be my slope. So all of that is exactly the same. Okay, all right, so let's practice this a little bit. So what happens here is if I look at this, this is going to be my k value. This is going to be the value that's telling me that I'm going to go down by 2. So my vertex here, my vertex is still going to hold true. So on my parent function, this point that I have here, this is still a vertex because it's where my two lines meet, and it is 0, 0. That's my vertex. So if I look at this, the x value here, my vertex x value is still going to be 0, but I'm going to start at a -2. So I have 0, -2. My a value here is 1, so my slope is going to go up 1 in both directions. So my very specific v is going to look like this. All right, now this time it's on the inside. So the inside means I'm going to move left to right, and I have nothing out here on the end. So my vertex is going to be 2, 0. 0 because there's nothing else out here. And then 2 because it's opposite of what we think on the inside. So I move 2, 0. Here's my point. My a value is still 1. So my absolute value looks like this. All right, here we go. We've got one we have both. So my vertex becomes -3, -1. Opposite, exactly what we think. So I'm going to go over 3 and down 1. And then my slope on this guy is still 1. That nothing here is changing. All right, now this is exactly the same as a parabola. So this just is going to tell us that we're going to open down, nothing different. So my vertex here is going to stay 0, 0. And now my slope is going to go down 1. So I have an absolute value. It looks like this. All right. Vertex on this guy is going to be -1, 3. And this tells me I'm going to go down. So -1, 3 is this point right here. And I have a slope of 1. So hopefully, if you were solid on quadratics, this should be piece of cake, right? 3, -2. So 1, 2, 3, -2. This tells me that I'm still opening down. Now let's do one more where we put it all together and we change our slope value. So this tells me now that I have a slope of 2. And unlike a quadratic, this is a literal slope. So this is going to be everything that I have here is going to be a rise over run of 2 over 1. It's not just the first point, it's all points. So I said every, but it's really all points. So my vertex here is 0, 0. But now I'm going to go up 2 and over 1. And I can do it again, up 2 and over 1. Now, what you're going to see on this, so this is my blue, this is my parent or my transformed function. I'm going to just do a little quick sketch here of my parent function. So my parent function has a slope of 1. So my parent function is this pink one. So this is going to be my parent function. Now, just like with a quadratic, what we find is when our slope is a big number, right, then it gets more narrow. And that's what happened here. So my transformed function is more narrow because a equals 2. This value of a equals 2. So knowing that, this is going to be even more, so EVEN, even more narrow, because this is a value of 3 versus 2. Now we see that it's also opening down. So my vertex here happens at 2, 0. So I go over here to 2, 0. And now I go down 3, 1, 2, 3, and over 1. So this is going to be even more narrow than this value of 2. Okay, now last thing that we have here, because this is a literal slope, we are going to do a rise over run. Now this is a little bit different than when we had a fraction with a quadratic. If you remember, I'm going to write this on the back. If I had 1/2 of x plus 1 squared, I have this point right here. We are not going up by 1 and over by 2. This is a quadratic function. So this is going to give me my u function. This tells me, so here's my axis of symmetry. This tells me that the next point over is going to be up 1/2. So I go right here, this point of 1/2. I don't go up 1 and go over 2. I just go to this point of 1/2, and I have this really fat, wide quadratic parabola, right? So over here, I literally have a slope of 1 over 2. So I get my vertex, and my vertex happens at -1, -3. And this time, I'm going to rise 1 and go over 2. And I can do it again, up 1 over 2, up 1 over 2. So what I see is what I expected, which is this absolute value function, this v function, to be super fat, because this is less than 1. Okay? All right, that's it for today. We're going to practice now.